Recording in progress.
This video covers the review guide for Test 5, Chapter 5. It's going to cover everything we've learned about polynomials and the quadratic formula and everything in between. So let me go ahead and get started. All right, so section 5.1 is just about multiplying polynomials. This is where you learned the FOIL method, and essentially you're just distributing. So we're distributing the first term in that first binomial to each term inside the trinomial, and then the same thing here. And when you use this method, you can this is where we sometimes use the multiplication setup. I sort of did a combination of that. Let me just show you because it gets really long. So if I use the first term, the x, this is just x times 5x squared plus x times 2x plus, I'm going to keep that negative with the 6. This is x times negative 6. Now I have to do the 4, distribute the 4. So that's 4 times 5x squared. This is when the multiplication method becomes really handy. 4 times plus 4 times 2x plus 4 times negative 6. Okay, so I'm going to go ahead and simplify the first few. So this is x times 5x squared. So this is just 5x cubed plus 2x squared plus, excuse me, I'll just keep the minus there. So minus, maybe. Let me, oh, okay. Keep it simple then.
Recording in progress.
Internet connection is struggling. Here we go. Minus 6x. All right, and then I know I've got the 4. This is that second term that I distributed. So I know I'm going to end up with an x squared term, and I'm adding it. So I'm going to put it under my 2x squared. So this is 4 times 5 is 20. 20x squared. 4 times 2x is plus 8x. And then 4 times negative 6 is negative 24. So in this case, I'm going to do it vertically. Add these together. So it just is 5x cubed. 2x plus 20x is plus 22x squared. Negative 6 plus 8 is plus 2x minus 24. And we are done. That is it. All like terms have been combined. We can't simplify it anymore. Excuse me. All right, so let's do it with number 2. So for number 2, we have a square of a sum. So you have to be careful. You cannot just distribute the exponent, to the 2x and the 3. You've got to actually write it out as 2x plus 3 times 2x plus 3, so that you can then use your FOIL method to multiply the terms times each other. So this is 2x times 2x plus 2x times 3 plus 3 times 2x plus 3 times 3. And now we can continue to simplify. So 4x squared plus 6x plus 6x plus 9. And we can then combine these guys and we end up with 4x squared plus 12x plus 9. And we are done. Okay, so factoring polynomials is where it got a bit more complicated. In this first one, you can tell by the variables that we have a difference of squares. So we have a c squared and we have a d squared. However, 162 and 8 are not perfect squares. Now I know that 4 is a factor of 8 and it is a perfect square. So I'm going to see if I can factor out a 4 or factor out a 2 and that leaves that a 4. And let's do that with this one and see what it gives us. Okay, so if we factor out a 2, we're left inside with 2 goes into 16 8 times, 2 goes into 2 1 time, 81. So that works. 81 is a perfect square. It's 9 times 9. So we still have, now we have a true it's a difference of squares. 81c minus 4d squared. Now, what we know about a difference of squares is that if you have, excuse me, Trying to figure out this way. So we know if we have a squared minus b squared, that equals a. Let me get this straight here. Well, that's not in parentheses. That is a plus b. It's a product of conjugates. A plus b times a minus b, because the middle term, which, like, if you look up here, the middle term, the 12x or the 22x or the 2x, those cancel each other out because one's positive and one's negative. So this is the pattern, the formula that we're looking at here. The 2 is going to stay there. But so let's just define our parts here. So going back to our original 81 c squared minus 4d squared. So a squared is 81c squared. That means that a is 9c. B squared was that 4d squared, and so b is 2d. So these are what we need to fill in the rest of our factored, our two binomials. So this is your a plus b and your a minus b. So that means that the rest of it is a, which is 9c, plus b, which is 2d, times 9c minus 2d. And that's it. You're done. Or those rules, the patterns that we know to look for. All right, so for number 2, we have 4c squared plus 12c plus 9. So 4, this looks like a perfect square trinomial because you're 4c squared, that's 2c, and then 9 is, or 2c squared, and then 9 is 3 squared. And so most likely we can simplify this. So if this is a x, well in this case it's c, but ax squared plus 2ab plus b squared equals, that would be a sum, a square of a sum. So that is your a plus b squared. So this gives us this, we have a perfect square trinomial, and that gives us the square of a sum. So that means that a is your, let's see here. So if ax squared is 4c squared, then a x is, or in this case, is 2c. And then if your b squared is 9, then b is 3. And so we would, these are the ones we're looking for here. So it's 2c plus 3 squared. All right, so let's check that and make sure that it works. I don't know if I can change colors or not. Oh, good. All right, so this will be our test. Now it won't go away, whatever. All right, so 2c plus 3 times 2c plus 3. So I know that 2c times 2c is 4c squared, and then plus 6c plus 6c plus 9. I combine these two, and I end up with 4c squared plus 12c plus 9, which does equal my original problem, and therefore we're correct. All right, so our solution is 2c plus 3 squared. All right, solve by factoring. This is one that drove y'all absolutely nuts. So both of these examples are a little more complicated because we have a coefficient of our squared term that is not 1. So easiest thing to do is I look at the factors that make up 3. This one's nice. It's a it's a prime number, so I don't have too many options. So I know that 3x times x gives me 3x squared. So I know the first term in both my binomials. I need to look at this negative 32. And we're probably going to use the 8 times 4. 8 times 4 is 32. We also know that we have 16 times 2 and 32 times 1, but we're probably not going to use that because we need some sort of sum here that gives us a negative 20. Now, I know that 3, and that again, we're multiplying the first factor. So we have 3 and 1. So if I multiply 3 times 8, that gives me a 24. And of course it's negative. So one of them is negative. So if I made that negative, that's negative 24. And the 4 is positive. So negative 24 plus 4 does equal negative 20. So I need to set it up. So I'm multiplying the 3 times the negative 8. So it goes here. And the positive 4 times just the 1, the x, coefficient of that x. And that gives me my solution. And I just kind of solved it. So you can do some trial and error here. But this is pretty much our factored answer. But now we have to solve it. So you take your first binomial, so 3x plus 4, and set it equal to 0. And then you have x minus 8 equals 0. Well, this is our easiest one, so I'm going to go ahead and add 8 to both sides. And I know that x equals 8. That's one solution. The next one, I subtract the 4 from both sides. 3x equals negative 4. Divide by 3. X equals negative 4/3. And that's our answer. Always 2. Mostly 2. There's one for each binomial. All right, so for number 2, it's a little more complicated, but it should look somewhat familiar. We just need to combine all terms on one side when we solve by factoring. So I'm going to subtract the 3 and add the 15q to both sides. So this ends up being 8q squared. 15 plus 8 is 23, minus 3 equals 0. So again, I have two options here. I have 8q and q to give me 8q squared, or I also know that 4q times 2q would also give me 8q squared. In this case, it's a little bit easier because my last term is the negative 3. So the factors of negative 3 are only 1 and 3 in some variation. One of the two is going to be negative. What I need to figure out is which one. So if I have 8q and q, the only number I can think of that comes pretty close to 23 is 8 times 3 is 24. And then 24 minus 1 is 23. So if I make that one negative and I put it with the 8, because I know I've got to multiply the 8 times a positive 3 to get a positive 24q. And negative 1 times q is a negative 1. So that gives me 24 minus 1, which would give me positive 23. And that's how I know that this is the variation that I'm looking for. So I have 8q minus 1 times q plus 3. Once you've done that, you then set it up so that you can solve to get your two possible answers, in this case for q. So 8q minus 1 equals 0, and q plus 3 equals 0. So we just subtract 3 from both sides, get the easy one done. I know that q equals negative 3. And for my second answer, I add 1 to both sides. So 8q equals 1 divided by 8. Let's cancel, and q equals 1/8. And that's my second answer. All right, let's move on to page 2. So for this one, we're given the answer, and we need to write standard form quadratic equation with the given solutions. So we're going in the other direction, which I know drives y'all crazy. Sorry. But it's actually a little easy. To me, it's much easier than factoring. You're not having to use quite so much kind of trial and error to figure out your different terms. All right, so you just set it up so that these, because they're telling you these are the answers. These are the solutions for x. So x equals negative 6 and x equals 9. So again, we just set it up so that everything is on one side of the equal sign and the other side is 0. So I just, in this case, add 6 to both sides. So I get x plus 6 equals 0. and I subtract 9 from both sides, x minus 9 equals 0. And I now have my two binomials, x plus 6 times x minus 9. Again, we're just going in the opposite direction. And now we can just use the FOIL method to solve. So x times x is x squared. X times negative 9 is negative 9x. 6 times x is plus 6x. And then 6 times negative 9 is negative 54. I combine my like terms. I get my final answer of x squared minus 3x minus 54. And I'm done. Well, it has to be an equation, sorry. So you also need to include the equal 0. But that's it. So x squared minus 3x minus 54 equals 0. All right, and then we do it again. I'm just giving you all some practice with fractions. What do we do with fractions? X equals negative 3/4 and x equals 2/3. Now, you do not add or subtract the fraction and just have x plus 3/4 equals 0 and x minus 2/3 equals 0. You need to have the form ax plus b equals 0. Oops. So what we do is we actually get rid of the fraction by multiplying both sides by 4 in this case to get rid of that denominator. Those cancel out and we end up with 4x equals negative 3. And then we add 3 to both sides. We get 4x plus 3 equals 0. I'm running out of room. And for the next one, we have to multiply both sides times 3. So we get 3x equals 2. And then we subtract 2 from both sides, and we get 3x minus 2 equals 0. So now I have my two equations, or excuse me, my two binomials. I have 4x plus 3 times 3x minus 2 equals 0. And we FOILed. 4x times 3x is 12x squared. 4x times negative 8x plus 9x minus 6 equals 0. Combine your middle terms. And your final answer is 12x squared plus x minus 6 equals 0. And we're done. All right, let's go ahead and finish this up. Solving by taking roots. We're having some practice working with square roots. So remember, if you have a negative inside a square root, we can't have that. That creates a complex number, which means it's imaginary. So you can just immediately rewrite this as the square root of 175i. And that's it. Now we need to simplify inside. Now I know that 25 goes into 175. Let's figure out, and 25 is a perfect square, which is what I'm looking for. So let's see, there's 4 in 100, 5, 6, 7. And 7's prime, can't do anything else with that. So I know that this is the square root of 25 times 7. 25 is 5 squared. So this cancels out and this cancels out. So only the 7, make sure that I stays with it. Only the 7 stays inside the square root. The 5 can come out. And we have 5 square root of, excuse me, hold on, move that I. 5i square root of 7. We're done. All right, 196, exactly the same thing. Immediately pull out that negative, and then you're just working with square root of 196i. Now, 196, I'm pretty sure is 14 times 14. 14 goes into 19 one time with 3 left, no, 5 left over. What am I doing? 5 left over. 14 goes into 56. 7 goes into it 8 times, so 4 goes into it 4 times. So yeah, 14 times 14. So this is the square root of 14 squared I. Those cancel out, and we end up with 14i, and that's it. Because there's no equal sign, we're just simplifying square roots. You don't have the plus or minus in front of it. All right, now we're solving by taking roots. We have an actual equation, so we need to solve. So when you solve by taking roots, you have to make sure that your squared term is on one side of your equal sign and everything else is on the other. So we have to move, that 256 is not a squared term. So we're going to move this over 256. So that leaves our x squared, which is the squared term, equals negative 256. Now we can solve, this is where you use the square root property. So we find the square root of both, x squared, well, that's just going to give us x, equals the square root of negative 256. So when you see a negative inside your square root, you should immediately know that on your answer, you're going to have an I, and the square root, the negative goes away. There's no negative in your answer. It's included in the I. Now, 256 is 16 times 16. Memorize that, but let me make sure that's 36. Carry my 3, that's 9. 6, 15, carry my, yep, okay, 256. So that means that that is the square root of 16 squared. So those cancel each other out. This does have an equal sign, so you have to make sure you have your plus or minus 16i. We're done. All right, I believe number 4 should give us a solution. Let's see what we get. Okay, so we need to isolate. So the squared term in this case is actually an expression. It's x minus 2 is being squared. So that's what stays by itself on the left side. We have to move this -4 to the right. So I'm going to add it to both sides. So I end up with x minus 2 squared equals 49. And now we can use our square root property. Square root of x minus 2 squared. These are going to cancel each other out. So we end up with x minus 2. And then the square root of 49, we know is 7 times 7. So this is plus or minus 7. Could be negative, could be positive, right? Because that is the square root of 7 squared. So that's where the 7 comes from. All right, so now that we've gotten rid of the squared part of the x minus 2, we can now isolate our variable x and add 2 to both sides. But we have to be really careful. There's 2 answers here. So that 2 is a solid, it's plus 2 no matter what. But we have to add 7 to it, and we have to subtract 7 to it. So we end up with two solutions here. So x equals 2 plus 7. 7 plus 2 is 9, and x equals 2 minus 7, which is a -5. And there's our solutions. All right, the last thing I'm going to do here is beginning of complex numbers, and then we'll finish the rest of this tomorrow. Now, the important thing with graphing these is your, and I'm sorry, it's really kind of hard to see. This is your real number, and this is your real axis, and I'm just making imaginary. This is your real term, and this is your imaginary term. So in this case, real is -4. So we're going to go left 1, 2, 3, 4. And the imaginary is positive. So we're going to go up 3, 1, 2, 3. So there is our point right there. When they ask us to find their absolute value, what they're asking us to find is the hypotenuse of this right triangle that we've created. So this is what we're trying to find. So we know that the absolute value of a complex number is the absolute value of the a plus bi, which is, I'm gonna make sure I write it correctly. It's the square root, because of the Pythagorean's theorem. C equals the square root of a squared plus b squared. So that's where this is coming from. A squared plus b squared. This is the formula to make sure that you understand. Now, the important part is A is the real number, -4. B is the coefficient of I, which is 3. So we plug that in to our formula, and we have -4. Make sure it's in parentheses because this is negative times negative, plus, I'll just put everything in parentheses, b squared, which is 3 times 3. So let's go ahead and solve this now. Square root, -4 times -4 is +16. 3 times 3 is 9. So we end up with the square root of 25, and therefore this is 5. 5 is the absolute value of this complex number. And then what quadrant does it fall in? Well, they're counterclockwise, so this is quadrant 2. Okay, all right, just in time. So that finishes what we covered on Tuesday, April 11th. We will finish the review guide on Wednesday, take the quiz Thursday, and then get a chance to look at it and maybe learn from some of our mistakes on Friday, and we'll be done. All right, thanks guys. Just send me an email or let me know in class if you have any questions.